on the Science and Policy Update on ocean acidification, a subject we haven't really talked about much in the Capitol, but it's time. I've noticed my staff cleverly called it the evil twin of climate change. I'll have to find out more about how they came up with that title. But having spent a few years working with legislators in Oregon and Washington, this isn't just something that California is waking up to. It's broader than that. It's broader than the West Coast, and it affects oceans all over the world. And most people think of climate change impacts relating to the coast as being sea level rise primarily. We haven't really focused on what's going on in the ocean. And so this informational hearing will consist of 3 expert witnesses. They'll speak for about 10 or so minutes each, and open it up for questions. We do have session today about 10 o'clock, so we'll probably adjourn about then, especially with the majority leader sitting here. I'm sure he'll make sure we're down on the floor. And so with that, welcome everyone, and thank you very much for attending. I have a few opening comments as soon as I find them. Ocean acidification, for those of you who don't have a working definition, we do have a handout that was prepared by my science fellow. Matt's done a great job, Dumlau, and preparing that in a language that we can understand. It gets a little wonky on page 3. A lot of letters and numbers. I'm not sure exactly what that all is, but we do know what the impacts are to ocean acidification. You've probably been following the effect on coral reefs, are particularly sensitive to changes in the chemical balance in the oceans. But right here along our own coast, the combination of ocean acidification as well as warmer ocean temperatures has caused a huge change in marine life, and that affects not only the environment, but the economic viability of our fisheries. So we have 1,100 miles of coastline. California really can't sit back without paying attention to this issue. And as far as I know, this is the first oversight hearing on this topic that the legislature's held, and it's frankly about time. With 1,100 miles of coastline, it's really important that we understand this issue so that we can maybe increase our mitigation. That means reduction of emissions of greenhouse gas emissions, because 25% of all the carbon dioxide we create as humans on the planet gets absorbed by the ocean. That's part of the challenge. Then with warmer temperatures and change of currents in the ocean, we're experiencing a change that will be alarming for many of us, and scientists are very much engaged. We have a report that's coming out that we're going to hear a little bit about in just a few weeks that'll look at ocean acidification and hypoxia, a term we will learn about more today. So with us, we have 3 distinguished witnesses. John Laird, Secretary of Natural Resources, chairs the Ocean Protection Council. For those of you who didn't know, we had an Ocean Protection Council. We do, also known as the OPC, and we have Ocean Science Trust. Welcome, Mr. Stone. We also have with us today Dr. Allie Bain, who's from Stanford, a distinguished marine scientist who's chair of the West Coast Ocean Acidification Hypoxia Task Force. That report is due in just a few weeks. And finally, Catherine Coleman, also known as Cat, from the Ocean Protection Council, who will tell us how the OPC has been engaged in this work. So let's start off with Secretary Laird. Welcome. Thank you for coming in so early.
You're welcome. Thanks for having me, and thanks also for doing this hearing and focusing on this issue. You mentioned the Ocean Protection Council, and 2 of us in the room were here for its creation, but it was legislation passed in 2004, and the desire is to have a high-level group representative of different agencies and departments that dealt with the oceans so that in a coordinated way you could cut through the silos and focus on the oceans. And Senator Pavley has sat as the Senate member and has been a very active participant. We're grateful for that, and helped on exactly these issues. Just sort of globally, the Ocean Protection Council, while it has a strategic plan that has a wide menu of things, they can really be lumped into 4 priorities of what the council's working on. The first one is fisheries management and the marine protected areas. It's the largest network off of any state. It's landmark legislation and a landmark program. The Ocean Protection Council is one of the key players in its implementation to really, on a scientific basis, look at fisheries and see how we can bring them back to sustainable levels off the California coast. The second thing that we focus on is marine debris and things that sort of from human activity go into the ocean. We have strongly supported local plastic bag ordinances and other things that deal with just what goes into the ocean. And when you get to the next category, you start to move into those that are inexorably linked to climate change. So we also deal with resiliency and adaptation. This organization did science unique to California on sea level rise. And as I'm fond of saying, on a day in 2011, we had the science presented to us, and at 8 o'clock that morning of the same day, the tsunami hit from Japan. I was watching live on KCRA. They said a coastal harbor. It turned out to be Santa Cruz Harbor. They couldn't even recognize from the air that a wave was coming in. And that was before sea level rise, at a time that it was low tide, and it gives you a hint of just what will happen over time with unchecked sea level rise in California. And so we have been tasked, along with other agencies and the Resources Agency in general, in working with local coastal governments to try to adjust and figure out how they plan and do it. But the fourth one, fourth priority of the OPC is the topic of this hearing. And it is really ocean acidification and hypoxia. And it really is the thing that I try to do any place I speak is point out how it is tied to greenhouse gas emissions. It is the one place that the ocean really just is at the mercy of whatever we do in the rest of the planet on land-based activities, primarily that are greenhouse gas emissions, because climate change is a major threat to the ocean. Rising ocean temperatures and increasing acidification are linked, as I said, to human activity. Unchecked, they will potentially destroy our ocean ecosystems and unravel the ocean food chain. And only the public can address these by reducing greenhouse gas emissions. And so everywhere I speak on this issue, I say it is greenhouse gas emissions that are linked to the future of the ocean. And that's why we are working with scientists, and you will hear in more technical detail in the next 2 presentations what has happened with that work. Because the ocean is the largest reservoir of carbon dioxide in the world. Ocean acidification, since the Industrial Revolution began, really is 30% more acidic, the oceans, and unchecked by the end of the century, it could be as much as 150% more acidic. And it makes it harder for organisms at the base of the food chain, including, I always have to look to name them, phytoplankton, corals, sponges, marine worms, and mollusks, to form protective shells and skeletons. That leads to their decline. It reverberates through the food chain, affecting other species that depend on them. And so the knowledge of these impacts is growing rapidly, and we can talk about it. Scientists have also documented an increase in frequency and size of the extremely oxygen-deficient zones in offshore waters that really are a key part of the greater acidification in the ocean. In 2002, for example, oxygen levels in waters just off the Oregon coast dropped nearly to 0, which kills or drives away thousands of sea creatures. And a zone of hypoxia has returned to the Oregon coast every year since for a period of time, which has implications for many important species such as Dungeness crab. So at the Natural Resources Agency, at the Ocean Protection Council, because the question then is, what are we doing, what do we do? And we convened a scientific panel to deal with this as the steps to do more science. And I always explain that it's really tied to greenhouse gas emissions, and there are a few near-shore impacts due to nitrates. I'm always asking the scientists when they update every time if it revises how you talk about it or it affects that. And that's known as the West Coast Acidification and Hypoxia Science Panel. They're releasing, as the chair said, their final recommendations in early April. And today, the chair of this panel, along with Kat Coleman, will share insights from the panel's work. And it's one of those times that you ask yourself, as an administrator, what could you do? And you can convene the scientists, make sure the science is up to date, and make sure we're talking out to Californians so they clearly understand what the science is and what the impacts are and how it ties to their own human activity. So in the light of these, we're identifying opportunities when the recommendations come out for decision makers to stay informed and become directly engaged in the panel rollout and the next steps. And I think we consider the legislature a complete partner in this, which is taking a look at this and deciding, are there things that everything we need statutorily in place? Are there other things that might be more helpful? Is it really about education of people, that they understand that when we are working on the governor's 5 goals on climate change, the oceans are at risk? This isn't the things that we usually talk about. And I will continue to explore and highlight how the work of my agency, others, and you can together tackle these problems and ensure that we're using the best thinking in science, policy, and governance to inform our action and to actually take action. I know together we can get it done, and I'm just pleased to be here to sort of set this high-level tone at the beginning, and would be happy to answer any questions that you might have.
And I'm just guessing you're not going to stay till 10 o'clock, so let's have a brief pause and see if there's some questions of Secretary Laird before we go on to our next 2 speakers. Senator Stone.
Thank you, Madam Chair and Secretary Laird. Happy New Year. It's nice to see you. You made a very important nexus here today. You said that the acidification of the ocean is a direct response to climate change. And my review of literature certainly says that that's hardly a settled science at all, going back to Dr. Freehy, who was a pioneer, as you know, in this studying. And as you know, he charted the pH of the ocean from 1988 beyond, discounting 80 years of data, and I think even his peers said that his study was fraudulent. And in 2012, at Scripps Clinic of Oceanography, they said that the pH varies naturally between different parts of the world, depending on the month and depending on the year. And I even think that the labeling of this as ocean acidification is really a misnomer. It's really alkaline, the ocean becoming less alkaline, because if you look from 1751 to 1994, the pH has gone, of the ocean, from 8.25 to 8.14. Granted, that's a 30% increase in acidity, but you have to understand how acidity is measured from 0 to 14, 14 being very alkaline, 0 roughly 1 in the stomach, so it's very, very acidic. So the acidity of the ocean can change in thousands of a percent. And so my concern is that we haven't studied this enough to come to any conclusions that alleged climate change is responsible for this at all. In fact, if you look at mussels in Scottish rivers where the pH has been down to 5.8, the mussels there thrive. So I would hope that we keep an open mind on this, and certainly it's appropriate to study it. I mean, this is our biggest reservoir of habitat basically on the Earth. We want to make sure that our crustaceans and the crabs and everything thrive, but it seems to me that we have a lot more work to do to make sure we get a real picture of what may or not be causing this. And also, What is the impacts of overfishing? And I think we'll all agree that we have pollution in the ocean that I would opine that does contribute to this, reducing the acidity of the ocean.
I think that's more like a statement, unless you'd like to make.
Well, I'd like to get his comments on this.
But we have, yes, the second and third speakers probably can speak specifically to the science part. And
That's exactly what I was going to say at the beginning, but let me say, I think the reduction of the acidification in the Scottish River and thus the improvement of the species in many ways proves the point. And really, it is science that is at the root of this, and I think many of us interpret the science in a much different way, and that is not to take away. I think my opening comments about 4 different priorities speak to exactly what you say. Just as in water, where historically there's been 2 or 3 big industrial projects and flood control, we now look at it as all of the above, that you have to do every single thing. That is also true with oceans. Even though I believe acidification is a real problem and the science supports it, that doesn't mean that we don't do fisheries management, connect marine debris, plan for the changing climate and what the sea level rise is. We are doing them all, and we have to do them all. But I think acidification is a key part of it, and I will let the scientists go into the point-by-point discussion of your comments.
very good. Yes, I think you're right, Secretary Laird, of having multiple impacts we have going on our coastlines, but we're looking at a global phenomena as well. Senator Monning, you had a question?
Thank you, Madam Chair, and thank you for convening this. Secretary Laird, always good to see you, and thank you for leading off this morning.
You represent a wonderful district.
We share a wonderful bay.
They set this up to each other.
We do.
Decide that this is the best area in the state, right? We know this.
Usually there's somebody from Santa Barbara on the panel that we have an argument with, but they're missing today.
Right. I think somebody farther south, Santa Monica's here. But we do hail from an amazing Monterey Bay region, protected in part by the National Marine Sanctuary, but certainly not immune from some of the elements you mentioned. And I appreciate your approaching the integrated nature, both the work of the Ocean Protection Council and then the 4 areas, and they are interlinked. And climate change, I would suggest, touches all of those areas. You mentioned particularly one of the focus areas being on debris, and I'm wondering if you have any further information of what the OPC or the state of California is doing. I know we're going to have a ballot measure on the plastic bag ban this November. You didn't mention styrofoam and its impacts in the Bay, but many of the communities in the Monterey Bay region have on their own passed ordinances to limit styrofoam, polystyrene products. Again, I don't think this is speculative in terms of the damage it's causing to fisheries and the ecosystems that depend on us preventing human insults to those areas. But could you comment maybe just a little bit on anything the state's doing on the debris issue?
Well, I think the state's doing multiple things, but in some cases, the local governments have had to step up where the state hasn't quite gotten there yet. And that was initially the plastic bag situation. And it's across the board, whether it is cigarette butts and certain filters, whether it's styrofoam. It's a question, and I think over time, the real question is how you do extended producer responsibility and packaging and other waste so that it doesn't go into the roads and streams and then the oceans in terms of pollution. And I teased one of my former colleagues in the legislature who was representing the plastic bag industry because he told me that plastic bags were recyclable and how good that was. And I said, isn't that wonderful? Because now we have a 250-year supply floating off the coast. And so it's a question of how we educate people and how we take that action. And at some point, the local governments have led the way, and they've done it issue by issue. And at some point, we have to do a more comprehensive look at that to keep things out of the ocean.
And it's fair to say that you're unequivocal in your belief of a nexus between greenhouse gas emissions and acidification of our oceans.
I am. And there were similar issues. I was on the floor as a member when AB 32 was adopted, and there were similar arguments made about cycles. And it is true, there are cycles, but these cycles are outsize anything that we have seen. And so I think it shows the different measurement of human activity on what might otherwise be natural cycles.
Thank you. Thank you, Madam Chair. I know we have other witnesses. So
We have other witnesses.
again, thank you, Secretary Laird, for being here.
And I had just one final question. I'm aware that there's openings at the Ocean Science Trust and the Ocean Protection Council. Their leaders or directors of those programs are moving on. So what is the timeline for replacing them? Here we have this hearing, and all of a sudden we have this sort of leadership vacuum. Do you have a time?
I think it's short on both, a short timeline that the administration hopes to fill them both. The Ocean Science Trust, the acting director is here, and we're really pleased that he, Mike DeLappa, has consented to assist over the short term. He's incredibly competent and brings a lot to it. And I know there's a process going on for the permanent director there, and I expect an appointment in the other one in a reasonable amount of time.
All right, thank you. Thank you for your attendance today.
Thank you for having me.
And while you're leaving your chair, let's call forward our next speaker, who probably can get into the science on a more detailed level. Dr. Boehm, if you would move forward, and looking for your...
Thank you for the opportunity to talk to you all today. And thank you, Secretary Laird, for that excellent introduction and giving half of my talk for me. So I'm going to make this short because I want there to be time for discussion, and Kat Coleman is also going to be presenting today. But I just want to reiterate some of the things that Secretary Laird said, which is that oceans are the largest carbon sink for the atmospheric emissions, taking up 30% of those. And so that's having effect on ocean chemistry. And there was some discussion of marine debris, and this problem is way bigger than marine debris. Marine debris is, it potentially could be solved or cleaned up. This is a huge problem that is going to be very difficult to stop and slow down. And this problem is going to affect our children and our grandchildren, and it's the problem that's going to define a generation. So it's really important, and I'm really happy that today we can talk about it. I need to be able to advance my slides, and I'm going to have to go grab the clicker.
Is it up here? Okay.
Okay, so I just want to point out that fisheries in California are very important, and you all know that already. They are worth billions and millions of dollars. And in the Pacific Northwest, ocean acidification is already having an impact, and it has cost them nearly over $100 million in jeopardized jobs. The shellfish industry in the Northwest is sort of the canary in the coal mine, and there's already been impacts to the shell fisheries in Washington, which is why Washington convened its own science panel a number of years ago. So this is a picture of a pteropod, and you can see it on the left. That's a healthy pteropod, and on the right is a pteropod that's actually been exposed to lower pH conditions that are presently seen in the ocean today. And these pteropods are not very charismatic organisms, but they are at the base of the food chain for a number of very important species in California. Herring, mackerel, seabirds eat them. They're important in the diet of crabs and rockfish. And this is also a sentinel organism, and a lot of research has been done on the pteropod, and it's already suffering because of ocean acidification. So let's talk a little bit about what is ocean acidification. This is increasing atmospheric carbon dioxide concentrations. You all have seen slides like this. And then we can put on their pH. And as we heard, the changes in pH don't look very big. They look kind of small. But those small changes in pH can have a huge impact on carbonate chemistry in the ocean. So if anyone in this room has ever taken an aquatic chemistry class, you know that carbonate chemistry in seawater is very complicated. And also it's important to note that pH is on a logarithmic scale. So a small change in pH actually means a bigger change in proton concentration in the ocean. Now this time series does not go back very far, and we already had a question about why is that? Well, it's very difficult to measure pH. Small changes in pH are very important, and the technology to make those measurements very precisely was not really around, and the pH sensors weren't calibrated correctly for a lot of these older measurements. So the time series that we have are very short. We need more time series like that. This is one of the best ones from Hawaii, from the Hawaii Ocean Time Series Station. So I don't want to go through carbonate chemistry with you because it's very complicated, but I just want to point out that pH is actually not the most important parameter for ocean acidification. So carbon dioxide dissolves in the ocean, it interacts with water and makes bicarbonate, releases a hydrogen ion, and then it interacts with bicarbonate. So what it's important to just take from this slide is that it's actually the carbonate ions that play a really important part in like calcifying organisms. And so we really care about carbonate, and that's affected by pH and how much is available for organisms. So it's the change in the carbonate chemistry that's a real concern, and that's why it affects shell-forming organisms. And there's another picture of a pteropod, an urchin, and a sea star, healthy ones versus organisms under what we're calling acidified conditions. It doesn't mean the ocean is acid, and it's not like stomach acid. It just means it's slightly more acidic, a slightly lower pH, and it can really affect the function of these organisms. They live in a sweet spot. And so this aragonite saturation is a parameter that we think is actually more important than pH for determining how OA, ocean acidification, is affecting organisms. If it's greater than 1, shells form. If it's less than 1, it's very difficult for shells to form. And so this is a projection of aragonite saturation in the ocean due to climate change. So there are the levels in the year 2000, on the left hand of the screen, 2050, and then 2099. And if you see reddish colors, that means that the aragonite saturation is less than 1, which means shell-forming organisms are going to have a very hard time surviving. And so you can see how that red color is becoming more intense. So very small changes in pH can really affect carbonate chemistry and make that carbonate not available to organisms that need it. So that's why small changes in pH are important. So why should we care about ocean acidification on the West Coast, and what are we doing about it? The West Coast is really vulnerable to OA, primarily because of upwelling, which is a process where waters that are cold underneath the thermocline upwell onto the coast, and those waters tend to have lower pH because a lot of respiration has occurred there. So upwelling brings low pH waters close to shore. This is just a cross-section through the water column showing pH varying with depth, and the blue colors show what in the ocean is really acidic pH. And so when that water upwells to the coast, it can really bring corrosive waters close to shore. I'm going to sort of speed through these slides, but I just want to say that we know that decreases in aragonite saturation affect shell formation, as I have said. This is a picture of oyster larvae under different conditions that are relevant to ocean acidification. And 3 hatcheries in the Pacific Northwest have suffered from acidification-related failures because those slight changes in pH have affected the success of the larvae there. Just want to point out that nutrients can play a role. Nutrient pollution can play a role in exacerbating ocean acidification. Don't want to go into too many details, but when you have nutrients enter the coastal ocean, you can have phytoplankton blooms, and those can, the organisms can die and sink, and when they're being remineralized at the base of the water column, you have protons being produced, which can create more low pH water. So for example, in the Gulf of Mexico, it's been shown that the nutrient pollution from the Mississippi River has made ocean acidification much worse there, and also in the Yellow Sea in China. And there's a number of publications in very high-profile journals about the interactions of nutrients and global climate change on acidification in coastal waters. So this is something that we need to keep our eye on. So on to the science panel, the West Coast Ocean Acidification and Hypoxia Science Panel. There are 20 members, leading scientists from the West Coast, including Richard Feely, whose name was brought up earlier, and Francis Chan from Oregon. The members of the panel come from California, Oregon, Washington, British Columbia, so it's a binational panel. And it is the Ocean Science Trust, which you heard about, is the organization that is providing support for the panel. So this panel was charged with summarizing the state of knowledge on ocean acidification and also coming up with, working with questions and issues that were raised specifically by managers from those states and from Canada, from British Columbia, about OA to address their concerns and needs. And so, as was mentioned earlier, the panel is not done, and we are coming out with a bunch of reports. And the most important one for you all is the executive summary, which is over here. You can't see the red. And we have 6 key findings, we have 8 recommendations, and we have 17 actions. Now, those numbers might change as we finalize our products, but the actions that we have are very actionable actions that we hope that managers and policymakers will take in response to our summary. Now, the key findings that we have, which I wrote here because I didn't want to put them in a presentation because they're not final yet. Where is my, here it is. So the 6 key findings that we have that we've decided and agreed upon as a panel of 20 experts are that ocean acidification will have severe ecological and economic consequences for the West Coast. So that's what the scientists are saying about OA. We are saying that global carbon emissions are the root cause of this. We are saying that there are actions that you can take now to lessen the exposure of organisms to OA. We are saying that you can enhance the ability of ecosystems to adapt to OA. And we are also saying that the science in this field is accelerating quickly. There's a lot of new research being done, and that's going to expand the number of management options available. Okay? And with that, I'm happy to take questions or go to Kat.